Imagine a time before time itself. There's no space, no matter, just an unimaginable point of energy. This is the singularity, the seed of our universe. Then 13.8 billion years ago, the Big Bang occurred. It wasn't an explosion in space, but rather the expansion of space itself. The universe inflated faster than the speed of light, a period called cosmic inflation. This rapid expansion stretched the fabric of space-time, creating the vast cosmos we observe today. The early universe was a hot, dense soup of energy. As the universe expanded, it cooled. This cooling allowed energy to convert into matter and antimatter, particles that annihilate each other upon contact. However, a slight asymmetry favored matter, leading to the building blocks of our universe. This asymmetry is why we exist today. It's a profound thought, a cosmic quirk that allowed for stars, galaxies, planets, and ultimately, life itself. The universe continued to cool and a pivotal transition occurred. Protons and neutrons, the building blocks of atoms, combined to form the first atomic nuclei. This era, known as nucleosynthesis, created the lightest elements, hydrogen, helium, and a trace of lithium. However, the universe was still too hot for electrons to bind to these nuclei. Light was constantly scattered, trapped in a cosmic fog. Around 380,000 years after the Big Bang, the universe cooled enough for electrons to be captured by atomic nuclei, forming neutral atoms. This event, called recombination, marked a significant change. The universe became transparent, and light was free to travel through space. This first light, stretched over billions of years, is what we observe today as the cosmic microwave background radiation. It's a faint echo of the Big Bang, a baby picture of our universe when it was just 380,000 years old. After recombination, the universe entered a period known as the Dark Ages. It was dark because there were no stars yet, only vast clouds of hydrogen and helium gas. Gravity, the architect of the cosmos, slowly began to pull these clouds together. Over millions of years, these clouds collapsed under their own gravity, becoming denser and hotter. Eventually, the temperature and pressure at their cores became so intense that nuclear fusion ignited. The first stars were born. These early stars were giants, much larger and hotter than our sun. They lived short, brilliant lives, fusing hydrogen into heavier elements like carbon, oxygen, and nitrogen. When these stars reached the end of their lives, they exploded as supernovae, seeding the surrounding space with these heavier elements. These stellar explosions enriched the universe, providing the raw materials for future generations of stars and planets. Section 4. Our Cosmic Address, the Milky Way, the Sun, and Earth's Genesis. Gravity continued to shape the universe, drawing together vast clouds of gas and dust to form galaxies. Our own galaxy, the Milky Way, is a vast spiral galaxy containing billions of stars. Within one of its spiral arms, about 4.6 billion years ago, a cloud of gas and dust collapsed to form our solar system. At the center of this swirling cloud, the sun ignited, blasting out light and heat. The remaining material in the protoplanetary disk, the remnants of the solar system's formation, began to clump together. Dust grains, drawn together by electrostatic forces, formed larger and larger aggregates. These aggregates, through collisions and gravitational interactions, eventually grew into planetesimals, the building blocks of planets. Over millions of years, these planetesimals collided and coalesced, forming the planets we know today, including our own Earth. Section 5. Life, the Universe, and Everything, from Single Cells to Sentience. Earth, in its infancy, was a hostile place. Volcanoes erupted, spewing molten rock and gases. The surface was bombarded by asteroids and comets, yet from this primordial soup, life emerged. About 3.5 billion years ago, the first single-celled organisms appeared. These simple life forms evolved over billions of years. Photosynthesis evolved, releasing oxygen. Eukaryotic cells emerged, leading to multicellular life. Life spread from oceans to land, diversifying. Primates evolved larger brains and consciousness. Humans capable of contemplating the cosmos had arrived.